This is lesson 4-7, driving data. Our quote is it sufficient that you have learned to drive the car, or shall we look and see what is under the hood? Most people go through life without ever knowing. Okay, so this basically means that we should understand a little bit more about the car other than just being able to mechanically drive it. Our objectives are to write, interpret, and use the distance formula and to use the formula for the relationship between distance, fuel economy, and gas usage. We have a bunch of key terms here. Some of them you may know, some of them you may not. The odometer, basically this indicates the distance the car has traveled since it left the factory. The trip odometer indicates the accumulated distance a car has traveled on a particular trip, and this is resettable, usually with a push button. Speedometer tells the rate at which the car is traveling. Fuel economy measurement, this is how much gasoline a car uses to travel a certain distance. Miles per gallon, or MPG, this is a type of fuel economy measurement which tells how many miles a car can travel on a gallon of gasoline. Kilometers per liter, km per L, this is a type of fuel economy measurement which uses the metric system. The English Standard System, this is a system of measurement used in the United States, and the metric system is a system of measurement used in most countries throughout the world, except the United States. So what data is important to a driver? Which is a greater distance, a mile or a kilometer? If you read a sign 100 miles to the Canadian border, would the numeral used to represent the number of kilometers be greater than 100 or less than 100? Well, 1 kilometer equals approximately 0.621371 miles, or 1 mile equals 1.60934 kilometers. So therefore, 100 miles equals approximately 161 kilometers, okay? All right, so let's look at an example. Let's say you get in your car and you travel at an average rate of speed of 50 miles per hour for 6 hours. How far does the car travel? Well, you might remember from some of your science or physics classes that distance is equal to speed times time, or rate times time, or d is equal to rt. So therefore d, rate in this case, is 50 miles per hour, all right? And the distance, the time is 6 hours. So if we multiply those two, we get the distance, which is 300 miles. All right, here's another example. Brian lives in New York and will be attending college in Atlanta, Georgia. The driving distance between the two cities is 883 miles. Jack knows that the speed limit varies on the roads he will travel from 50 miles per hour to 65 miles per hour. He figures that he will average about 60 miles per hour on his trip. At this average rate, for how long will he be driving? Express your answer rounded to the nearest tenth of an hour and to the nearest minute. All right, so we're going to use the same formula we used before of d equals rt, but now we're going to have to solve it for t. So we're going to divide both sides by r, and we're going to get the formula time is equal to distance divided by speed. So therefore, the time, we know the distance is 883 miles. We know he's going to be averaging. Remember, he said he was going to average about 60 miles per hour. So if we divide these two, we come out with 14.7 hours. Now, 7/10 of an hour, remember there's 60 minutes in an hour, so if you take 7/10 times 60 minutes, we come out with he will be traveling for approximately 14 hours and 42 minutes. Okay, so now we're going to be traveling north. So our next example, Kate left Albany, New York, and traveled to Montreal, Quebec. The distance from Albany to the Canadian border is approximately 176 miles. The distance from the Canadian border to Montreal, Quebec is approximately 65 kilometers. Now remember, Canada uses the metric system while we use the English, or whatever you want to call it, system. It's not really the English system anymore, since England doesn't use it. If the entire trip took her about 3.75 hours, what was her average speed for the trip? Well, first of all, let's convert the 65 kilometers to miles. So we know that 65 kilometers is 0.621371 miles. So if I multiply those out, I come out with her 65 kilometers in Canada is equivalent to a little over 40 miles. Okay, so if we add that to her 176 miles she's traveling in New York, we come out with her total travel distance of approximately 216.4 miles. Now again, we're going to be using the distance equals rate times time, but this time we're going to solve for rate or speed. So rate is simply equal to distance divided by time. So the distance we know is 216.4 miles. We figured that out. And we know her trip took about 3.75 hours. So we divide that by 3.75, and we come out with her average speed of 57.7 miles per hour. Now that is using our standard measurement system. So what if we wanted to figure out what her speed was in kilometers per hour? Well, then we have to convert our 176 miles in New York to kilometers. So we're going to multiply that by 1.6, and we come out with approximately 283.2 kilometers that she will travel in New York. Now we know she's traveling 65 kilometers in Quebec, so we add those two, and her total distance in kilometers now is 348.2 kilometers. Now, using our same formula, but now using metric measurements, her rate is equal to her distance, 348.2, divided by the time. By the way, time is the same whether you're doing metric or English. So 348.2 divided by 3.75. Her speed in kilometers per hour is 92.9 kilometers per hour. This compares with her speed of 57.7 miles per hour. So when you're driving in Canada, you may look like you're driving at a really fast speed because you might be going 100 kilometers per hour, but in reality you're going about 60 miles per hour. So here's one more example. Juan has a hybrid car that averages 40 miles per gallon. His car has a 12-gallon gas tank. So your average is 40 miles per gallon, 40 mpg, and he has a 12-gallon gas tank. How far can he travel on one full tank of gas? All right, so the distance he can travel is equal to miles per gallon times the number of gallons, okay? So his miles per gallon times the number of gallons. His distance, we know he can average 40 miles per gallon, okay? And he has a 12-gallon gas tank. So if we multiply those two, the total distance, or the maximum distance he can travel on a full tank of gas is 480 miles. All right, here's yet another example, probably a little bit more practical example, especially for a salesperson. When Barbara uses her car for business, she must keep accurate records so that she will be reimbursed for her car expenses. When she started her trip, the odometer read 23,787.8, okay? When she ended her trip, it read 24,108.6. Barbara's car gets 32 miles per gallon. Her tank was full at the beginning of the trip. When she filled the tank, it cost her $24.06. What price did she pay per gallon of gas on this fill-up? All right, so we got a fairly complicated example here. Let's see what we have to do to solve it. All right, the first thing I'm going to do is figure out how many miles she drove. So if I take the two odometer readings and subtract them, I come out with the fact that she drove 320.8 miles. All right? Now, next, distance is equal to miles per gallon times the number of gallons. So we're going to try and figure out how many gallons of gas she used. So if I solve for gallons, or G, I get that G is equal to D over M, or distance divided by miles per gallon. We know that her car gets 32 miles per gallon, all right? And we know that she traveled 320.8 miles. So if I divide those two, I come out with the fact that she used just a little bit over 10 gallons of gasoline. All right. Now, it cost her $24.06 for those 10 gallons of gasoline. So how much was it per gallon? So if we divide those two numbers, 2406 divided by the number of gallons she used, which is 10.025, we come out with she paid $2.40 per gallon for gasoline. All right, here's example 6. On a trip through Canada, Angie noticed that the average price of gasoline per liter, now this is the price of gasoline per liter, remember Canada is on the metric system, was 1.28 Canadian dollars, okay? So if you stop at a gas station, it would say 1.28. Now, that's not $1.28. It's Canadian dollars, but it's per liter, not per gallon. If $1 okay, is equivalent to approximately 1.39 Canadian dollars, and this varies, by the way, from day to day, not too significantly, but so this is sort of an average here. What is the equivalent price per gallon in U.S. currency? All right, so let's see what this comes out to be. Well, first of all, I know that 3.8 liters, okay, is equal to 1 gallon. The way I remember it is a liter is approximately equal to a quart, okay? It's not exact, but it's approximately, because normally we'd have 4 quarts in a gallon. Well, there's 3.8 liters in a gallon. And if I turn it around the other way, 0.26 gallons, or in other words, about a little more than a quarter of a gallon, is equal to a liter. And we were also told that $1 was equal to 1.39 Canadian dollars. Now, whenever I do a problem like this, I like to keep the units, because the units help me to figure out how to do this. All right, I want dollars per gallon as the answer, okay? So I know that 1.28 Canadian dollars, okay, per liter. That's the price of the gasoline at the gas station up to K. Excuse me. Now, I want to cancel out liters, and I want to cancel out Canadian dollars, so I end up with US dollars and gallons. Well, I can cancel out liters because I know that 3.8 liters is equal to 1 gallon. So here, the liters cancel. All right, now I got to cancel out the Canadian dollars. Well, I know that $1 is equal to 1.39 Canadian dollars. So in multiplying, I can cancel out the Canadian dollars. So what am I left with? I'm left with US dollars per gallon. And if I multiply the numbers, I come out with $3.50 per gallon. So as you can see, the price of gas in Canada is significantly more than what the price is in the United States.